Today, let us talk about the ordinary least squares. So if you remember in the last class, we've defined what is a population regression function, what is a sample regression function. Now we are going to find out a method through which the sample regression function is going to be as near as possible to the population regression function, right? So can we find that out? Uh, so we'll start writing with what is a population regression function, which is yi equals to beta 1 plus beta 2 xi plus ui. But note that this PRF is not directly observable. It is not. So we have to use a sample. Do we have the entire population with us every time? No, we don't have. So we have to estimate it using a sample regression function. But PRF is not directly observable. Right? We estimate it from SRF. So we get the estimate for the true value of beta 1. What is that? Beta 1 hat. We get the estimate for the true value of beta 2. What is that? Beta 2 hat. We get the estimate of UI. What is that? UI hat. Residual, right? So beta 1 hat. So yi hat is what? Beta 1 hat plus beta 2 hat. Xi plus ui hat. Yi is yi hat plus ui hat. So you know now that this is the estimated y. And this is your residual, right? Which is the estimate of the error term. Okay, then how do you write ui hat? Yi minus yi hat. So residual is nothing but the difference between the actual y and the estimated y. And the entire econometrics is based upon reducing this difference between the actual y and the estimated. So we need to do that. What is estimated y? Beta 1 hat plus beta 2 hat. If you minus sign it is beta 1 hat minus beta 2 hat xi. So you've just written what is yi hat. Okay, so we may adopt the following criteria. We may adopt the following criteria, right? So one thing we can do is that we can choose the sample regression function in such a way that the sum of the residuals is minimum, or the sum of the residual is as small as possible, right? Because our entire exercise is based upon reducing this difference between yi and yi hat. Shows the SRF in such a way that the sum of residuals, summation of ui hat, is as small as possible. is as small as possible. So let's say this is your sample regression function, right? And these are the different values of x, x1, x2, x3, x4, and so on. So let's say we have these different values. These are the actual values of x1, x2, x3, x4, right? These are the actual values here, right? And this is the estimated value of x1. So this is the estimated value of this y1, right? These are the estimated values. No? These are the actual values of y1, actual y1. This one is estimated y1. Estimated y1. So the difference between the two is nothing but the residual. U1 hat here, this is the difference. U2 hat here, this is the difference. U3 hat here, this is the difference. U4. You understand? So for x1, this is the actual value of y. But what we have estimated of y is this much using this sample regression. Using this sample. So what is the sum of the residuals? U1 plus U2 plus U3 plus U4. Right? Now, if you look at it, this is the sum of the residuals which you have. Now, don't you think that we are giving equal weights to each of them? All of them are given equal weights. Do you think that we should be giving them equal weights? No. There are some residuals which are very far, I mean, some estimated y's which are very far off than actual y, and hence the residual is large. There are some estimated y's which are near to the actual y, and hence the residual is less. So, but still we are giving them equal weights. So note that. In this case, we are giving equal weight to all the residuals. All the residuals they are given equal importance no matter what, no matter how far they are from the actual one, right? So even if they are more scattered around this sample regression function, then also they're giving the same weight. Then the residuals which are very, very near to the sample regression function. Are you with me? So no matter if the residuals are widely or closely scattered around the sample regression function, they are given equal weights. So what is also possible is that if you are giving them equal weights, then this is possible. Then this U1 hat is equal to U4 hat, this U2 hat is equal to U3 hat. तो ये तो प्लस है, let's say ये माइनस है, ये प्लस है, ये माइनस है. तो ये, I mean, in case if you add them, then there is a possibility that this sum is equal to 0, which you don't want, right? So it is possible that the algebraic sum of these residuals is 0. Although U1 hat and U4 hat are scattered more widely than U2 hat and U3 hat. So you're getting the point. It is possible that U1 hat plus U4 hat, they will cancel out each other. U2 hat, U3 hat will cancel out each other. So on the face of it, you will feel like, oh wow, I mean, the sum of residuals is equal to 0. So might have made a very good model, because on the sum of all these errors is equal to 0. But no, I mean, your residuals, they're widely scattered. If these residuals would have been very closely scattered around the sample regression function, this would have been good for you. But this is not good. So you have one of the residual which is very widely scattered as compared to this one. So you can't say this is a very good model. So there's a problem with this. So now what is the solution? The solution is that instead of minimizing the sum of the residuals, why don't you try to minimize the sum of squares of the residuals? In that case, you will be giving the different weightage to the different residuals. Those who are widely scattered will be given more weight. Those who are less scattered will be given less weight. So you will understand now. So you're not giving equal weight to all kinds of residuals. So that is the point. Please write this. We can avoid this problem if we adopt least squares criteria. So what is summation of ui hat? Summation of yi minus yi height. But we want to minimize not just the summation of the residuals, we want to minimize the sum of the squares of the residuals, right? This beta 1 hat beta 2 hat xi square as small as possible. So the moment you are trying to minimize the square of the residuals, you are giving different weight to the residuals, right? Those who are very widely scattered will naturally be getting more weight, right? So by squaring, ui hat, this method gives more weight to the residuals such as u1 hat and u4 hat, than the residuals u2 hat and u3 hat, right? Than the residuals u2 hat and u3 hat. यही तो देख रहे हो आप. So the more widely scattered these residuals, more weight you are giving. Less widely scattered the residuals, u2 hat and u3 hat, they are less widely scattered around the sample regression function. They will be getting the lower weight. Right. Under the minimum summation ui hat criteria, that is when you just are minimizing the sum of residuals. Criteria. The sum can be small even though ui hat are widely spread. Isn't that true? So you can have, let's say, I mean, what about this? You can also have this one, this one, this one, this one. They are very, very widely spread. But this is canceling this. This one is canceling this. So in a way, you can get a sum which is equal to 0, even though UI hats are widely spread. But this is not possible. Not possible under least squares criteria. Least squares method. That is for the larger UI hat. अगर देखिए जब आप स्क्वायर्स को मिनिमाइज कर रहे हैं, देखिए यहाँ पे प्रॉब्लम क्यों आ रही थी, why the problem was occurring. So for example, this is 2, this is -1, this is +1, this is -2. So when you are adding just the sum, it is 2 - 1 + 1 - 2 cancelled. But if you are adding a square of these residuals, so there is no point it could be made equal to 0. Unless they are actually 0. It is actually here, 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 and here. So that is not possible. So it is not possible that you can have a widely scattered residuals and the sum of the squares of residuals is very minimal. No, that's not possible. But this is not possible under the least squares method, that is for the larger UI hat. Larger is the summation of UI hat square, right? Summation of UI hat square is yi minus beta 1 hat minus beta 2 hat xi ka square. So this is the function of what? Beta 1 hat and beta 2 hat. Beta 1 hat and beta 2 hat. So I'm going to stop here. And in the next class, we're going to start from this particular point where we are ending. So I hope it was useful to you. Thank you, Beta.